We are talking about properties of rational exponents and radicals. And before we can get into some example problems, we have to remember the relationships and the definitions that will help us answer these questions. So exponent rules. To start with, we have to set the base or to understand what each variable means. So let A and B be real numbers. So real numbers, anything that's not imaginary. So negative values, decimals, fractions. And let M and N be rational numbers. So those are fractions, that any number that can be expressed as a fraction, such that the quantities in each property are real numbers. So again, we're not dealing with imaginary numbers. And then here are some definitions that we can work with. These are going to be review for a lot of us. So the first one, product of powers. If we have the same base, in this case our base is A, and they're raised to two separate exponents joined by multiplication, we can add the exponents, and there's the example over there. Power of a power. So if we have a base and an exponent, and then that's raised to another exponent, in that case, all we do is we can join those two exponents together by multiplication, leave the base the same. Power of a product, and that kind of looks the same way as it would look if we had a coefficient out front of the parentheses. What we're going to do is we're going to distribute the exponent to both parts of the product. And so we have A to the M, B to the M. If we have a negative exponent, so A to the negative M, what we can do to get rid of that negative is we can move the base and the exponent to the denominator, and then we make the exponent positive. In this case, A cannot be 0 because we cannot divide by 0. The 0 exponent just means any base raised to the 0 power is going to be equal to 1. And again, A cannot be 0 because 0 to the 0 power does not equal 1. The quotient powers, quotient of powers, A raised to the m power divided by A raised to the n power is equal to, so basically if we have the same base with different exponents, we can rewrite it as whatever the base was, and then we take the two exponents and subtract them. A cannot be 0, again, because we can't have 0 in the denominator. We can't divide by 0. Power of a quotient, A divided by B raised to the m power. That is similar to product of power, or excuse me, power of a product, where we're going to distribute. So we take the m and we distribute to the numerator and the denominator. So A to the m divided by B to the m, where B cannot be 0 because we cannot divide by 0. We have some properties of radicals. So here, and this works both ways. The first one we have is product property of radicals. So if we have two numbers underneath the radical joined by multiplication, we can write them separate, where we leave the radical the same, or we leave the root the same, and we just split the two bases up. This works both ways. You can start here and split it up if that helps you out, or you can start separate and join them together like we did here. You can say 3 or the cube root of 8, and you can split that up to the cube root of 4 times the cube root of 2. Those are the same, but if it helps us out where we join these together, so we say 4 times 2 is 8, and then we do know that the cube root of 8 is 2. So whichever one helps us out, whichever version, we can either start with it separate and bring them together, or we can start where they're together and we can separate them if that helps us out in a problem. Quotient property of radicals. And this is similar to the power of a quotient and the power of a product, where we're basically just going to distribute the radical. So we have the nth root of a over b, and we can distribute that where we have the nth root of a divided by the nth root of b. Those are the same things. One more thing we have to consider is because a variable can be positive, negative, or zero, sometimes absolute values need an absolute value is needed when simplifying a variable expression. There will be some problems where it says assume all positive. So absolute value is not needed when all variables are assumed to be positive. So if the directions say assume that all variables are positive, then we don't have to worry about this. Now, we don't have to worry about it either when we're talking about the nth root is odd. And so if we have the nth root of a to the n is odd, that's going to be equal to x. So the seventh root of 5 to the 7th is equal to 5. So the base was a positive value, and we got a positive value. Same thing where we say the seventh root of negative 7 to the 7th. When we do this math, we get negative 5. So there's no there if the radicand, the number under the radical is positive, we're going to get a positive answer. If the number under the radicand is negative, we're going to get a negative answer. That's if our radical, our nth root, is odd. We have to consider is when it's even. We have to use the absolute value. So if the nth root of a to the n, where n is an even number, we have to use the plus or minus, or we can use the absolute value. So 3 to the 4th is 81, and then we take the 4th root of 81, that's positive 3. And if we have negative 3 under the radical, negative 3 to the 4th power is 81, and then we take the 4th root of 81, and we get 3. So when we have an nth root that's positive, we have to consider both the plus or minus, just like when we're solving the quadratic functions or the quadratic formula. That's why we have to use the plus or minus for that answer.